All right, you have your lab notebooks out. Up at the top, in the title, write Physical and Chemical Change Lab. In the box where it says experiment number, write 1. Our beginning question is, how can you distinguish between a physical and chemical change? All right, so you're going to write that in your lab notebook up at the top. You can abbreviate beginning question BQ if you like. The background information, physical change, a physical change, you have no new substance that has formed. The examples of this would be phase changes, boiling, melting. Also, if you cut something in half, if you paint it, all of those are examples of physical changes. A chemical change, you have a new substance formed, and examples of that would be if something is flammable, that means it can catch on fire and it's going to have a chemical change occur. If something is corrosive, it can react with metals. If something is toxic, toxicity. Okay, if something is combustible. All right. Now write a heading of procedure in your lab notebook, and we're going to do these activities. Now, I think I've said to you before, we're going to draw things because I think that helps make it a little more concrete. So I'm going to move this over here. In your lab notebook, write procedure. By the way, you have plenty of space in your lab notebooks. Okay, if you fill the lab notebook up, I will give you another one. So do not cram everything into one little tiny area. Write nice and big, take up space. Remember, these old eyes have to grade it. All right, so at each lab station, you're going to have some activities. The first thing you're going to do is you're going to take a piece of chalk and you're going to crush it in the mortar and pestle. Okay, so the chalk will become powdered. In the second part of your lab notebook, after you do that, you'll write down whether that was a physical or chemical change and what your evidence is that it was physical or chemical. Okay. Step 2, still at the same section, you're going to take the chalk that you crushed and you're going to put it into a beaker and you're going to add vinegar. Okay, you'll have a container with vinegar in it. And you will add that, and you'll make observations. Then you're going to write in your lab notebook, what do you think? Was it a physical change or a chemical change? Step 3, you'll move to a new station. And again, this is in order. I'm thinking first lab station, second, third, and fourth. You guys are all going to start on a different lab station. So you may not be starting with this direction. If you're starting at lab station 4, you're going to probably start at with a different number. In fact, what I think I'll do is this. Well, I don't want to do that because now you can't see it. I'll do this. This will be at 1. Now we'll go on to lab station 3. This will be not lab station 3, but this will be the second lab station. Step 3, you're going to measure out 40 milliliters of water into a beaker. And you're going to stir in a scoop of sugar. And I actually think I'll probably leave little packets of sugar because I have those. So you can, instead of using a spoon of sugar, you can just put a packet in. Okay? And record your observations. Step 4, you're going to take about 40 milliliters of water again. And you're going to add it to a beaker, and this time you're going to put drops of food coloring in. Just do 1 drop and observe. This I'm going to put at the second lab station. Okay? Third lab station, you're going to take a straw and blow bubbles into the beaker with colored water. So, we've got a beaker, and you're going to have a straw in there, and here's your mouth. You're going to blow into that. Some very 80s hair with big curls. And you're going to blow bubbles and observe what happens. The next thing you're going to do, and this will be lab station 3. Lab station 4, we're going to get an Alka-Seltzer. So it'll be in a package, and you're going to break it apart. And you're going to put it in to a beaker. Step 7, you're going to put 40 milliliters of water into that beaker with the Alka-Seltzer halves in it, and observe what happens. Alright, so you have this water with the Alka-Seltzer in it. The other thing you're going to put in there, is a thermometer or a temperature probe. It just depends on what we have available. But you'll put a thermometer or a temperature probe in there, and you're going to look to see what happens with the temperature. Drop your Alka-Seltzer pieces in, observe. Okay? Step 8, you're going to light a match, and then you're going to look at it for a bit, and you're going to blow it out. I realize some of you may have never lit a match. If you haven't, you get to play with fire. Okay? So you're going to light it, and then you're going to blow it out. Okay? Step 9, going to light it again, the match, and this time you're going to light a candle with it. And you're going to observe the candle. Don't blow it out. So this will be at station 5. Then eventually you'll have to blow it out before you leave. So leave it lit until you're ready to leave. Okay? So now we're going to take... Why didn't it want to move? Okay, there we go. A beaker. Actually, we're not going to use a beaker. You're going to take a 3x3 piece of aluminum foil, 3x3 inches. Ironic, because we should be using centimeters, which would be 6 centimeters by 6 centimeters, or 7 centimeters by 7 centimeters, actually. And you're going to kind of fold that up so you've got a little bowl. Okay? You're going to put a pinch of sugar into that bowl. And then you're going to use the crucible tongs. And the crucible tongs are the ones that they have two kind of flat areas that meet, and then they kind of go like that. So you're going to use the crucible tongs, and remember I said blow out the candle. If you did, relight it. Because you're going to put it over the flame and observe. And then after you've observed, then you can let it cool and you can throw the aluminum foil away. This will be at station 6. Okay? Clean up all your stations. Okay, so clean up as you go, really. If you light a match and it's out, make sure it's out, and then you can put it in the trash. But clean up, and then you're going to answer the questions. So you're going to look at each substance thing that happened, and you're going to think, did I make a new substance or not? If you made something new with different properties, that's a chemical change. If it's still the same substance, it's just changed how it looks, that's a physical change, and you need to share your evidence. Evidence is going to be things like it's still, let's say you have ice and you're crushing up ice. So you would say it's still ice, it's just in smaller pieces, but they have the same properties. Your evidence for something new is that it's going to have changed properties, and you might also, some of the signs that it may have become something new are when you have a color change, if you have a lot of heat and energy produced, if it gets cold. Now, obviously, something freezing is going to get cold. So these are not always ironclad ways to tell whether you've got a new substance or not. But if you have gas produced, if you have light and heat given off, those are examples. Color change, a precipitate, if a solid forms at the bottom, those are examples. That's evidence that you had a chemical change. So you're going to fill that out. Then I want you to think about your beginning question. The beginning question was, how can you distinguish between a physical and chemical change? And you're going to write me an answer about that. How can you tell if it's a physical change or a chemical change? And then you're going to use your evidence. So you might say, melting water is a physical change. We know this because we melted water and it is still the same thing. Or the water would have the same properties. Melted water, melted ice, duh. Or you might say melting water is a new substance because it gave off a lot of energy. Something along those lines. But use some of your evidence from up here. Okay? Then you're going to tell me why your evidence works. So if you have a color change and you say a chemical change occurred because we got a color change. Color changes are often found when you have a chemical change occurring, and you're going to get some more notes tomorrow, and that will be in there as well. All right? That is what you need to do. So you need to write an answer to your beginning question, support it with evidence, and then tie it all back into the definition of physical change and chemical change. Thank you very much.